CSIR Success Story webinar. As a brief, I would like to inform all our viewers that as India turns 75 years after independence and CSIR completes its 80 years of service to the nation, this webinar series has been initiated to celebrate Azadi Ka Amrit Mahotsav and also the remarkable 80 years of CSIR. In this webinar series, we are showcasing the success stories of CSIR from its laboratories spread nationwide. And today's webinar is in fact the 45th one in the series. The topic of today's webinar is Steel Slag Road, a sustainable green utilization of steel slag in road construction, and has emerged from one of CSIR constituent laboratories, CSIR, Central Road Research Institute, CRRI, situated in New Delhi. CRRI is a premier research organization of CSIR that work towards highways traffic and transport planning and has a vast and unique variety of infrastructural facilities to undertake research and consultancy activities related to road and runways, traffic and transportation, bridges and geotechnical aspects. Today, this webinar is to showcase the technology developed and implemented by CRRI for use of steel slag, which is one of the major solid wastes in the steel making process for an eco-friendly and sustainable construction of roads. And to know about the technology and the developments, we are today connected with experts, Director CSIR CRRI, Dr. Ranjana Agarwal, Dr. V.K. Saraswat, Member Niti Aayog, Mr. Paramjit Singh, Additional Industrial Advisor, Ministry of Steel, Mr. Aruni Mishra, Vice President, ArcelorMittal Nippon Steel India, Mr. Satish Pandey, Principal Scientist, and Mr. U.K. Guruvittal, Chief Scientist, both from CSIR CRRI. I am Dr. Shikha with you, Scientist from Science Communication and Dissemination Directorate at CSIR Headquarters, and I welcome you all once again for the webinar. We shall begin our talks with an opening remarks by Dr. Ranjana Agarwal, Director, CSIR CRRI. Dr. Ranjana is PhD from Kurukshetra University, and after carrying out her postdoctoral research at Cambridge University, she once again joined Kurukshetra University as a lecturer in 1995 and served till the level of Professor of Chemistry and the Director of Women's Studies Research Center at the university, before taking the charge as Director of another CSIR laboratory, CSIR NISPER. Dr. Ranjana has taken up additional charge of Director CSIR CRRI since last few months. Dr. Ranjana's research contributions have been acknowledged in the form of awards, notably Dr. Basudev Banerjee Memorial Award of 2014 by Indian Chemical Society and Professor S.S. Katiyar Endowment Award of 2015 by Indian Science Congress. So I request Dr. Ranjana Agarwal, Director CSIR CRRI, to kindly deliver the opening remarks for the session. Over to you, ma'am.
Thank you very much, Shikha. Respected Dr. V.K. Saraswat, Member Niti Aayog, who is keynote speaker of today's success story webinar. Shri Paramjit Singh ji, Additional Industrial Advisor, Ministry of Steel. Shri Aruni Mishra, Vice President, ArcelorMittal Nippon Limited. Shri Guru Vittal ji, Chief Scientist of CSIR CRRI. Our technology developer, Dr. Satish Pandey, who is with us. Members from Ministry of Steel and our industry partners, ArcelorMittal, SAIL, Tata, JSW, Bharat Ispat Limited, who are joining us online, and members across the CSIR and science enthusiasts who are joining us through webinar. I welcome you all from my own behalf and on behalf of CSIR CRRI to this CSIR Success Story webinar. CSIR CRRI, Central Road Research Institute, is very proud that one of its success stories is being shared for this Azadi Ka Amrit Mahotsav, and it is one of the 80 stories of CSIR. As Dr. Shikha mentioned, Central Road Research Institute is a premier national laboratory which is dedicated for having R&D activities in roads and transportation. There are several R&D activities which are going on in various divisions, in various fields. But if I have to club them into 4 verticals, I would like to put them in the technologies. That is for design, construction and maintenance of roads and runways. How we can bring about technologies which are affordable, sustainable, safe and long-lasting to build the infrastructure of Indian roadways and highways. Uh, for planning of traffic and transportation of mega cities, which is a big challenge, environmental pollution and road traffic safety and analysis is another vertical where CRRI is working on. CRRI is also engaged in developing technologies and processes for landslide control, ground improvements, disaster mitigation infrastructure, and it provides evaluation services and monitoring services for life assessment and rehabilitation of highways and railway bridges. CRRI always believes for the sustainable development and how the waste can be converted into wealth. That is an aim. And with keeping this in mind, there are several technologies which are being developed and which have been developed in the recent past. I would like to name a few where the waste has been utilized as a resource material so that we can save our natural resources, be it bitumen or our aggregates, and also how to conserve energy and the natural resources otherwise. Biobinders have been developed from the bio waste. Particularly, we are working on the rice straw and waste plastic. One of our CSIR laboratory at Dehradun Indian Institute of Petroleum is producing the biomass, and I am very pleased to inform that CSIR CRRI has developed biobinder which has 30% of biomass substituting bitumen. So it's a like big replacement. 30% of bitumen will be replaced by biobinder, where we are using rice straw. Parali is a big problem of northern part of India. All the testing has been done and we are like on the final stage of testing it. Simulation in the lab is going on. So this technology is almost on the advanced stage. Similarly, waste, plastic waste is a big menace and it's a global challenge. CSIR CRRI has got 3 patents on wet technology of using waste plastic, whether this is PE or thermocol or PVC. Industrial waste is again a big problem, whether it is from the steel industry or the zinc industry or copper industry. So solid waste is a big challenge, how to mitigate that. So in this connection, steel slag in iron and steel industry, where 26 million steel slag is produced in India, and how to manage that steel slag is a big challenge. India is the second largest country to produce steel slag, and the way exponential growth is going on, we expect that in coming time, this steel slag will be a bigger problem. So to tackle this problem, Ministry of Steel, then steel industries, JSW, Tata, ArcelorMittal, Bharat Ispat, all have joined hand with CRRI and how to look forward to convert steel slag into steel slag aggregate, how to replace steel slag aggregate with the natural aggregates. And today's story is how steel slag has been converted into steel slag aggregate, the technology developed at CRRI, and how ArcelorMittal has constructed steel slag road at Surat, Gujarat. And a proud moment that India Book of Records and Asia Book of Records has included this steel slag road, which has been built with 100% processed steel slag aggregate has been included into this. So this is a very proud moment. Today we have with us Dr. V.K. Sarswat, who has been guiding us throughout this project. And today when he is with us and he as a keynote speaker, will be telling us more insights and how to take it further, the future roadmap, how we should move ahead. So he is with us. A very warm welcome to Dr. Sarswat and thank you very much for joining us. Industry partners and ministry. I think this this success story is a beautiful example that how stakeholders, if they come together from the very beginning, inception of the problem, inception of the technology, if they join hand and monitor the progress of the technology development and take it to the lab to land. So the success is inevitable, and this is a beautiful example. So not taking much time, I would like to thank once again Dr. Saraswat, Shri Paramjit Singh ji, and Shri Aruni ji for joining us. Thank you so very much. I believe the audience will be amused by the story of steel slag aggregates in building infrastructure of India. Thank you so very much. Namaskar.
Thank you very much, ma'am, for the welcome and for delivering the opening remarks, giving us a brief overview about the institute, about the activities of CSIR towards waste to wealth development. So this is really a great initiative, and we'll be taking it up further as a success story here. And we're moving ahead. We are privileged today to have with us Dr. V.K. Saraswat, member Niti Aayog. Dr. Saraswat is a distinguished scientist with vast experience in defense research. He retired as Secretary, Defense Research and Development Organization, DRDO, and after more than 4 decades of government service. He holds a PhD from Osmania University and an ME from Indian Institute of Science. Dr. Saraswat, in his professional career, has chaired several positions, including Homi Bhabha, Chair Professor and Consultant to IOCL R&D, Chairman of NTPC R&D Advisory Council, Chairman of the Committee for Development of Indian Microprocessors, and several others. Currently, he is the member of Niti Aayog and has initiated the Methanol Economy Program for transportation, energy generation, and production of chemicals, fertilizers, etc. Dr. Saraswat is a recipient of many awards, and most notable among them are Padma Shri in 1998 and Padma Bhushan in 2013. He has been conferred honorary doctorate by more than 25 universities, and the latest among them being by Jamia Hamdard in 2018. So here, as Madam told, he will be showing us the roadmap ahead. I request Dr. Saraswat to kindly deliver the keynote address for today's session. Over to you, sir.
Namaskar, good afternoon. Thank you for the nice introduction. At the onset, I would like to congratulate CRRI and ArcelorMittal and others who have joined together in this major venture of setting up this road in Surat using the steel slag. I still remember my meetings on this subject at IIT Bombay and even in Niti Aayog, where we have identified various pathways for utilizing steel slag, and one among them, of course, was the laying down the roads using the aggregate and things like that. So it's a good story which is now taking good shape, and my congratulations to all the participants who have made it possible. All of us know that Indian steel industry had paramount importance and complex challenges for sustainable solid waste management. It is being generated during various operations. One such emerging and aggravated solid waste problem is the steel slag. And iron and steel making processes generate huge amount of slag, which is basically, what is slag? Which is basically a non-metallic product consisting of calcium silicates and ferrites, combined with some fused oxides like iron, aluminum, manganese, magnesium, calcium, phosphorus, and so on. But it has some tremendously good properties. Due to its high strength and durability, it can be processed to aggregates of high quality, comparable with those of natural aggregates. The high bulk density, high level of strength and abrasion, as well as the rough texture quality, steel slag has a construction material. So steel slag has many well-known applications in road construction, such as hot mix asphalt, cement concrete mix, anti-skid layer, granular base and sub-base layers. It also meets all important physical characteristics of aggregates laid down in the Ministry of Road Transport and Highways specifications for Road and Bridge Work 2001 for preparation of bituminous concrete mixes. And as I mentioned to you, we are very happy that India's first ever steel slag road, made up of 100% processed steel slag, has been built in Hazira Industrial Area, Surat. It was developed by ArcelorMittal Nippon Steel in collaboration with CSIR, CRI, and I think some credit can be even given to Niti Aayog for initiating the dialogue. If you look at technical aspects of this steel slag, basically iron and steel slag can be divided into two parts. One is the blast furnace slag, which basically emanates to granulated blast furnace slag and air-cooled blast furnace slag. Another one is the steel making slag, which comes out of the converter and the electric arc furnace. So if you look at all of them, the scheme of different unit processes in making steel slag, slag formation, treatment, and product application is basically from all the EAF, AOD converter, ladle furnace, BOD, continuous casting furnaces, all of them actually lift slag. So slag has to be actually given some treatment. It could be a mechanical treatment, it could be pyro treatment or hydrometallurgical treatment. Ultimately, it leaves two elements. Element one is the metallic element, which can be reverted back into the furnaces. And element two is the one which is inorganic part, which has got, which can be used for internal recycling or PCC products or geopolymer, cement, pillars, fertilizers, infrastructure construction, and so on. Certainly, the last point I would recommend is the landfilling. We should not use it for landfilling at all. If you compare the properties of the steel slag with natural aggregates, you will find that in terms of density, it is better than the natural limestone. In terms of bulk density also, it is better. Abrasion is slightly lower than the natural limestone, which is 13.2 versus 23.0 for the limestone. Crushing value is almost equal, and water absorption is better. So looking at all these properties, I think it makes a good sense to utilize it for different applications. Now, there are two ways of doing this. One is the untreated steel slag coming out from blast furnace, blast oxygen furnace, or EAS, or ladle furnace, where untreated conventional slag can be used for road, pavement, hydraulic engineering, fine aggregates, SCMS in CM, and so on. There are challenges in this route. One is which is because of the volume instability and potential heavy metal leaching, which is actually present in this, and low cementitious activity. This is another major problem. Another area is where you take the slag and co-treat it with carbon dioxide. So direct carbonation, it gives you products like aggregates, artificial reefs, abiotic catalyst, and SCMS in cement. There are lots of benefits of this because you get through this stable volume, you get excellent strength, you get low and heavy metal leaching. So that is advantage. And indirect carbonation, if you take, you will get PCC, silica gel, adsorbents, soil conditioners, which has a lot of benefits like high value added, carbon credits also you can derive from this. And of course, it is a big case for resource conservation. So in other words, if you look at the primary uses are in the cement and the road construction, and the secondary uses will be heavy metal remediation and mine site rejuvenation and carbon sequestration. There are economic and environmental benefits of all of these co-products because they generate revenue, they prevent the landfills, they increase the resource efficiency, they reduce carbon dioxide emissions, and it improves the soil health, it enhances the environmental production and soil remediation and revegetation. So there are tremendous amount of advantages, and one should look at all of them in big way. We should also look at what exactly world is doing in this. If you look at all the countries like Japan, Europe, USA, China, most of them have been using it for road construction. For example, Japan, the total slag which they produce, 32% is in road construction. Europe is about 43%. USA is 49.7%. And of course, China is small in this particular case. And many of them are using for cement production and a bit of them for agriculture. Of course, China is famous for doing it for final disposal, which is not known even today what they're doing with it. But certainly there is a pathway which doesn't seem to be in line with the sustainability goals. Now, what is the status of slag generation? Madam Rashmi Ranjana ji mentioned about the status of how much slag we are producing. The steel industry in India is producing about 24 million tons of blast furnace slag and 12 million tons of steel slag annually. It is expected that the blast furnace slag generation may reach around 45 to 50 million tons. And DOF slag around 15 to 20 million tons per year by 2030. That is the kind of projections which have been made. So you can imagine what is the extent of wealth which we are creating, which can be certainly made use of. EAF and IAF slag generation is also expected to increase to more than 10 million tons per year from the present level of around 5 million tons per year by 2030. In the past, of course, utilization of steel slag was very low, except for some mixing in the sintering, which has resulted in the accumulation of large quantities of steel slag in every plant. In fact, I was pained when I visited some of the steel plants like Durgapur and all that. The whole 10 kilometers stretch on the boundaries of the steel plant were flooded and loaded with the steel slag all around. It's not a good sign. I think it should be a major program should be launched for its utilization. I am sure it must be there in other steel plants also. So there is a tremendous need for us to now give a major push to this. It is estimated that more than 30 to 40 million tons of steel slag may be lying in various steel plants. This is what worries me. So how do you capture and store it by mineralization? So what carbon capture can be done? It is possible to operate a CO2 capture process based on a reaction with steel slag on an industrial scale, since steel slags are often cheap and readily available near large CO2 emitter sources like cement plants and steel plants and so on. If physical or chemical methods can remove the barrier layer during the reaction, the steel slag carbonation may be more natural to implement as a large-scale industrial application. In addition, we can modify the mineral phase composition of the steel slag, which gives calcium and magnesium in the sensitive phase of the carbonization reaction. It has a positive effect on the application of steel slags in carbon capture and sequestration. Slag 2, which is the precipitated calcium carbonate, is a relatively complete process for co-processing steel slag and carbon dioxide and is presently under investigation in pilot and laboratory scales. The energy input requirements of the Slag 2 PCC process and the full economic and environmental benefits of the PCC still need to be systematically evaluated. But I think this is one pathway we should look at, because it is a sure short case of carbon capture and utilization and storage. The assessment results may differ for different countries and regions, which may be related to the scale of the steel mill and the distance between the steel mill and the application plant of the PCC. So from all this, what is important and what we have discussed on various meetings, there has to be a major program as far as steel slag utilization is concerned. And the research kind of thing which has been done by CRI and also the participation of industries like ArcelorMittal, I am very happy that we are moving in the right direction. But the need of the hour is for scaling up these operations, and translation should take place. All more industries should come. Better standards should be prepared. Achieving full potential of the resource efficiency in the steel sector with respect to steel scrap processing and slag utilization in India would require significant innovation efforts, ranging from the adoption of latest technology and equipment, logistics support, and of course, we have to evolve some new business models also. This cannot be achieved by incremental evolution within the existing systems. It will require rather holistic and possibly radical change of the existing production and consumption systems. The responsibility should be with the OEMs who are producing this slag, and they have to make the necessary investments both in research and development and also application. To support the transition to resource efficiency with respect to steel scrap processing and steel slag utilization, we also need to create a coherent policy framework, and major policy innovation will be needed, which can address all technical and non-technical issues, including financing, capacity building, supply chain management, etc. So it becomes very important for us to give kind of a holistic, overarching solutions. And there is a need for us to look at right from the steel ministry to the steel plants to the sale and all the private steel manufacturers, that this is one of the manners which is being created, but it has got a lot of value, and this value should be harnessed. And if it can be used for carbon dioxide sequestration, or used as part of the circular economy, where instead of mining the limestone for aggregate, if we can use for this, we will be doing a lot of service as far as the sustainability is concerned. So looking at all this, the multiple applications, I strongly recommend that there has to be a policy framework quickly. Steel Ministry should take major initiative in that respect, and the industry should come through a public-private partnership and create the necessary ecosystem in the country for slag utilization. I wish this dialogue which has been organized by the CSIR CRI will certainly pave way for this kind of a thinking, and more stakeholders will do their bit to make steel slag as part of the circular economy. Thank you very much for inviting me. Thank you all.
Thank you very much, sir, for your keynote address, giving us a brief overview of steel slag and its application, the processes and the challenges in construction of road using steel slag. Also informing us about the worldwide scenario of the use of this steel slag for different applications. And also for briefly showing the road ahead for resource utilization at its best. So thank you once again. So now we have a speaker from the Institute who is principal scientist at CRRI and the principal investigator of the project for steel slag road construction, Mr. Satish Pandey. Mr. Pandey is BTech in civil engineering and has MTech with transportation engineering specialization from IIT Delhi. He has been associated with CRRI as a scientist since 2006. In his 16 years of long research career in the field of transportation and highway engineering, he has been associated with the development of new technologies and cost-effective materials for construction, maintenance, and rehabilitation of roads. He is the recipient of CSIR Young Technology Award 2017, Scotch Gold Award 2020, and also the Best Guide Award 2004 by Indian Concrete Institute and ACC Cement. Mr. Pandey has served as a council member of Indian Road Congress, ASSOCHAM, and FICCI. He, along with his team, has undertaken major R&D initiatives in the institute, one of the major one being the steel slag road construction project. He has also contributed immensely to the development of Indian Road Congress specifications, guidelines, and BIS standards. So with this, I invite Mr. Satish Pandey to kindly share information and his experience with the work related to steel slag road construction. Over to you, Mr. Satish Pandey.
Thank you very much, Shikha Madam, for the brief introduction. And at the outset, I would like to express my sincere thanks and gratitude to Dr. Saraswat for enlightening us with his kind words and showing us the roadmap to scale up the technology. I hope my presentation is visible on the screen.
Sir, your presentation is not visible. Another screen is popped up.
Just a minute. Is it visible now?
Yeah.
Yeah, so I'm going in full screen mode.
Please go ahead.
Is it okay?
Yes.
But can you listen me? Is it okay?
Yes.
Yeah, it's fine. Fine. Please go ahead.
Please go ahead.
So first of all, very good afternoon to all the participants. So without taking much time, I would like to give you a brief overview about the steel slag and its potential utilization in road construction. So as sir has informed that around 19 million ton steel slag is generated annually in India in different integrated steel plants. And as per the national steel policy, we are envisaging the steel production will be around 300 million ton by the end of 2030. So by that time, we will have 45 to 60 million ton annual steel production in the country, and the disposal of such huge solid waste will be a challenging task to steel industry. On the contrary, like for the construction and maintenance of vast road network in India, we require 1.1 billion ton natural aggregate annually. And this quantity is expected to increase 2.2 billion ton in upcoming years under the massive road development program undertaken by National Highway Authority of India in the form of National Highway Development Program, Bharatmala project. And besides that, under Gati Shakti, PM Gati Shakti Pariyojana, the several new infrastructure projects are lined up. Now, what is the Steel Slag Road? Like this is the road which has been built under the CSIR CRRI technological supervision and guidance using 100% processed steel slag aggregate as substitute of natural aggregate and good earth. It's a 6-lane bituminous pavement comprising uh, uh, earthen layers as well as the asphalt layer on top of it. This road connects NS6 to Hajira Port. It's a heavy duty pavement and subjected on 1000 to 1500 trucks, commercial trucks on everyday basis. It's a The major benefit of this particular construction is that we have replaced entire natural aggregate and good earth using processed steel slag aggregate. The aggregates are utilized in the construction of subgrade, subbase, base course and bituminous layer. The partial utilization of steel slag as a substitute of natural aggregate were attempted in different parts of the world as well as in India. But the unique feature of this particular project is that we have replaced entire natural aggregate and good earth using processed steel slag aggregates. So we built 3 test sections in this particular projects. First test section is a control section which has been built for the comparative study using conventional natural aggregate, and it is this particular section is designed for 100 million standard axle repetition for 20-year design life. And according to Indian Road Congress prevailing specification, the thickness of the section is worked out to be 625 mm for the road which is supposed to be built using conventional natural aggregate section. So thus we kept the length of this control section is around 200 to 250 meter, and another test section we built it using 100% processed steel slag aggregate without reducing its thickness. So the length of this test section is around 300 meter, and the third test section has been built by reducing the overall thickness of the road by 32%. So in place of 625 mm thickness, we built the road with 425 mm thickness, and the major reduction is carried out into dense bituminous macadam layer and wet mix macadam layer, which are considered as a costliest pavement layer inside the pavement structure. So with the help of that, we significantly saved the construction cost. We evaluated this is a completely
I think there is some connection error.
Yeah.
Satish ji, are we connected?
I think we have lost him.
Yes, I think we have lost. He will reconnect again.
Shall we move ahead with our next speaker? Let Satish ji come and join. So, Satish ji?
I think Dr. Shikha, can you not call him, because this was a very interesting part.
Yeah, actually we would like to hear first about the technology.
I think he has joined back now.
Oh, sir, madam, am I audible to you?
Yeah, yeah.
Some
Yes,
technical
please
glitch,
continue.
so there is a breakdown the internet connectivity. So in this particular photograph, you can see that the heavyweight deflectometer evaluation is carried out on steel slag road test section. We tested this road as per the IRC parameters, and at 40 kilonewton load, you can see the deflection in the road which has been built through natural aggregate is around 371 to 260 micrometer. But in comparison to the road which has been built through 32% reduced thickness, there is a significant reduction in the pavement surface deflection by 50 to 60%. So by virtue of that, this particular road is considered as more stronger than the road built through natural aggregate, and we can effectively reduce its overall thickness of the road by 30 to 40%. So this is one of the major benefit of constructing a road using 100% processed steel slag aggregate. So we can not only prolong the service life of the pavement, as well as we can conserve the natural aggregate and national resources for the construction of roads in the country. Now this is a small video which shows you the journey of the steel slag road construction and processing. So I'm just playing and you can have a glimpse of it. Now, this particular short clips gives an aerial view of this road, like how it looks after the construction. So we evaluated this road on different serviceability parameters, and it is meeting out the different parameters as laid down for the construction of national highway in the country. So this is glimpse of an overall road, like on what type of traffic it is subjected and how it looks like. And this entire pavement is constructed using 100% processed steel slag aggregate, including median, shoulders, and side drains are built through processed steel slag aggregate. So it does not contain any sort of natural material inside it. Only in the top layers, the bitumen is used along with the processed steel slag aggregate for the construction purpose. And so the different type of challenges we have addressed for the steel slag utilization in this journey are like the volumetric instability, as the sir has discussed, like steel slag shows volumetric instability due to the presence of free lime and magnesia. So we modified the steel slag cooling process so that the stable mineralogical phases can be formed, and besides that, the requirement of weathering can be further reduced. So this sort of distress cannot occur in the pavement in case of processed steel slag is intended to be utilized for the construction purpose. The second important challenge is the tufa formation, since the steel slag aggregate normally contain high amount of calcium oxide, between 45 to 54%. And this calcium oxide, by virtue of carbonation process, form the calcite deposits on the on the surface, which can impede the drainage characteristic of the pavement layer. So with the help of altering the slag cooling methodology, as well as by modifying the weathering process, we can reduce this tufa formation process in the steel slag aggregate. And the third important aspect is the vesicular structure of the slag. So conventionally, steel slag looks like that, but with the help of modified steel valorization technology developed under this particular study, this vesicular structured slag is successfully converted in the form of an aggregate. So this is a glimpse of a processed steel slag aggregate, which more or like looks like a good quality natural aggregate, so that it can be utilized without any sort of issue in road construction work. The fourth important aspect is the chances of erosion inside the pavement mass. Like in case slag is intended to be utilized for the construction work, then there may be the probability of formulation of uh, uh, chances of corrosion on the steel slag aggregate surface. So we developed the customized process to reduce this corrosion aspect by limiting the metallic iron presence inside the slag aggregate. So ideally, the metallic iron content inside the steel slag aggregate should not be greater than 3%. Accordingly, we set up the entire process in this FSNL plant situated at AMNS Hajira. So it's a magnetic drum separation process. So we customize the gauge setup inside this magnetic separation process, so that it can effectively reduce the metallic iron content from the slag. And once it is less than 3%, it can be utilized without any sort of issue for the road construction activity purpose. The last but not least, the another challenge is the possibility of heavy metal leaching. So in case of unprocessed slag is utilized in bulk quantity for the pavement construction, then there are the chances that like high pH leachate can emanate from the deposits of slag, and which can contaminate nearby water bodies as well as land. But in case the processed steel slag, which has stable mineralogical phases, is will be utilized for the construction purpose, then these type of aggregate are not showing any sort of leaching under adverse environmental condition. We conducted TCLP test with the help of National Environmental Engineering Research Institute, Niri, Nagpur, and none of the processed steel slag aggregate exhibit any sort of heavy metal leaching during this testing process. So this photo gives you a glimpse of the conversion of steel slag into processed steel slag aggregate. So at the first pic, you can see the unprocessed slag. The second one is showing the slag with vesicular structure. Now the third one is the processed steel slag aggregate, which has been emanated out of the CRRI study. And fourth one is the steel slag fine, which we have utilized for the construction of subgrade and embankment in the particular project. And this is the short view of a processed steel slag aggregate emanated out of the CRRI study. So in terms of the techno-economical feasibility, the processed steel slag aggregate is costing between 150 to 220 rupees per ton, particularly at AMNS Steel Surat, Hajira Surat plant, while in the nearby areas, the good quality natural aggregate is available between 250 to 475 rupees per ton, depending upon the size. Since this aggregate has a slightly higher specific gravity, therefore per ton transportation cost of this material is comparatively higher than the natural aggregate, but this increase in transportation cost can be easily overcome by the initial production cost of the slag. So at last, this utilization is not going to become uneconomical, and in case if we reduce the overall pavement thickness, then the road construction cost can be further reduced by 30 to 40%. So one of the major interim finding of this particular study is that like processed steel slag aggregate can be utilized as 100% substitute of natural aggregate in all layers of bituminous pavement, including median and shoulder portion. Load carrying capacity of steel slag road is found far better than the road built through natural aggregate. So even we applied the load up to 140 kilonewton, which is far higher than the specified limit in Indian Road Congress guideline, but at 140 kilonewton load also the measured deflection is comparatively lesser than the deflection measured into natural aggregate road built through natural aggregate segment. The riding quality parameter of steel slag road is at par with the road built through natural aggregate, while steel slag road is even exhibiting better skid resistance under wet conditions. So this is another important benefit of using steel slag road. The overall pavement thickness can be reduced by 30 to 40% by using processed steel slag material in all pavement layer. And one of the most important benefit is that like use of processed steel slag aggregate with reduced pavement thickness will render the steel slag road approximately 30 to 40% cheaper than the road built through natural aggregate in that particular region. So this is the glimpse of some of the media coverage carried out in various leading newspapers. So under this particular study, we also developed Center for Research on Steel Slag with the financial support of Ministry of Steel in CRRI campus. And this particular setup is equipped with state-of-art facility to characterize the steel slag aggregate and to facilitate its long-term utilization and road construction activity. So these are the major facilities under CRSS in CRRI campus. Now that's all from my side, and I am giving a thanks to all the participants for attending this presentation. Thank you very much.
Thank you very much, Mr. Satish Pandey, for your talk informing us about the steel slag road construction, the technology and its actual implementation for road construction in Gujarat. So moving to our next speaker, Mr. Paramjeet Singh, who is Additional Industrial Advisor, Ministry of Steel. Mr. Paramjeet Singh is B in Metallurgy from Punjab Engineering College and has more than 29 years of professional experience. He has worked for nearly 21 years in industrial consultancy and on job training in the field of steel making, rolling mill and reheating furnace, and has been associated with the Ministry of Steel for more than 4 years. So I invite Mr. Paramjeet Singh now for his input on the topic of the talk today. Over to you, please.
Thank you, Dr. Shikhar. Thank you for the introduction, and good afternoon to all of you. I am really happy to hear that the project what is being honored to CRRI for the use of steel slag has given some, you can say, some breakthrough outcome. As Dr. Saraswat has already informed that he has in a brief way, he has informed that where the slag is being generated. One is the blast furnace, other is the steel making area. The steel making area, there are two types of slags being generated. One is the lactic arc furnace and the LD slag. The result, what is being shown by Dr. It is mainly on the electric arc furnace. I think the work when we basically honored the project to R&D project to the CRRI, the main objective was this, that we have to find the ways and means to utilize the LD slag, and later we included the electric arc furnace slag. That I am happy that one part is complete now, that the electric arc furnace utilizer has come out with a you can say successful results. As Dr. Saraswat has told that in integrated steel plants where this blast furnace route and BOF route, LD converter route is being used, the lot of slag is lying, only 20 to 30% is being, you can say, reused in the plant, but balance is being, you can say, lying in the plant. Lot of you can say slag is lying in the plants. And if we go according to the envisaged, you can say, capacity by 2030, the 300 billion ton capacity and the production around 255, and the more and more slag will be generated, and we want that maximum utilization should come, because if we see that right now whatever the slag is lying over there, if we find the suitable result for the utilization of the slag, that land which is occupied by the slag, that can be used for the further green field expansions. That will be, you can say, one of the big breakthrough. I'm happy that that CRI has done a very good, has shown a very good result, that by using this slag, there is a lot of benefits that because they are going to reduce the cost of, you can say, and the road, and the strength of the road is better as compared to the natural aggregates. Though I hope that the same way we will get the result of, for the LD slag, and whatever the slag is lying in the plants, that will be utilized at the earliest. I just want to inform to you, Dr. Saraswat, that we have taken other projects also for the utilization of the steel slag. One is in the agricultural field that we have given to the IARI. They are also working for the utilization of this steel slag for the as a soil conditioner or to develop the fertilizers. And the one project we have already given to the CBRI for the use of aggregates by replacing the natural aggregates in the building construction. So we, whatever the guidelines, or you can say directions given by you, we will definitely follow that guidelines, and we will find out that wherever the slag can be used, we will happy to get the you can say projects from the different organizations for the utilization of the slag. One another input, sir, I want to just convey, just to inform to you that earlier, whatever the R&D projects were given by the Ministry of Steel, they were not having the, you can say, industrial participation. But since last 2 years, we have increased the industrial participation so that the commercialization of the project should take place. In the similar way, that whatever the project we had given to the CRRA, they were having the participation from the Tata Steel, AMNS, GSW, and the SAIL. The similar way, the ARI project, what I have been given for the is all the three major steel producers are involved in that. And I hope that through these efforts, we will definitely find out the you can say utilization of waste, and we will secure the, you can say, natural aggregates, natural resources, and we will go toward the you can say sustainability and ecosystem, whatever you have informed, sir. This is what the submission. I congratulate CRRA for the results, and I again just request them to work on the LD slag so that we can utilize it at the earliest as it is possible. Thank you very much.
Thank you very much, sir, for your valuable inputs from the side of Ministry of Steel and for connecting with us today. So we'll be moving to our next speaker. We have an industry expert connected with us today, Mr. Aruni Mishra, Vice President of ArcelorMittal Nippon Steel India. Mr. Aruni Mishra is MBA by qualification and is working as Head of Byproduct Sales at ArcelorMittal Nippon Steel India Limited at Hazira, Gujarat, and is responsible for a special drive on marketing of steel slag in various areas. Mr. Mishra has been instrumental in associating with organizations like CRRI, IDSO, GERI, GERI, and other government departments in promoting the use of steel slag as a replacement of natural aggregate. So with this, I invite Mr. Mishra for his talk. Over to you, please.
Thank you, Dr. Shikha. That was a very nice introduction. I don't know whether I really have that much on my credit, but that's fine. First of all, I would say that, talking in a forum which involves CRRI makes me feel that I am back home, because my father retired as a senior scientist from National Metallurgical Laboratory in Jamshedpur after serving for several years there. To begin with, Dr. Saraswat, I would first like to recollect and remind you of one of our meetings when we met in one of the conferences, and I was explaining during the conference as to what all efforts we are making towards sustainable use of slag. And at that point in time, you told us, ये सब मत बताओ, ये बताओ तुमने किया क्या है, कहाँ पे रोड बनाया है, क्या किया है. So that was something which I always remember, that unless we in the industry we showcase our efforts by something like what we have made here in Hazira, it is very difficult to please a policymaker. But then I to some extent dedicate this effort of ours to you, Dr. Saraswat, because I feel that unless there is a collaboration between policymakers, scientists and industry, I think as country it is very difficult for us to succeed. So I feel that this particular road that we have made here in Hazira is it's totally dedicated to this trio of policymakers, scientists and industries. I definitely owe a lot of efforts have gone into making of this road, and CRRI has been very much instrumental. In particular, I would like to thank Dr. Satish Pandey for his continuous push and effort in providing us with the right technology, in also, making, making certain changes in our practices to make this slag, particularly usable for road making. And also, I would like to thank the Steel Ministry for, taking this effort and bringing the industry together in this effort. See, I would just like to say that here at AMNS, we are, totally committed to sustainable practices and decarbonization efforts. And we have demonstrated our effort in this direction by investing in this road. Although it is a small road, but I feel it's a big leap into future where the use of steel slag will go a long way, and we will find a big market for it. So when I say market, I would like to share the agony of a salesman when you go out and try to sell something to the users. Actually, you find very few takers, because takers to use the slag in a commercial manner. See, the first statement that you hear from people, अरे ये तो waste है आपके लिए, इसमें why are you thinking that some value can be created? But that is not so. We are making lot of efforts. We are investing into making it useful for the industry, useful for the country, and that needs to be appreciated. And I feel that this particular effort of making this road, although small, will give that authenticity to use of slag. And I'm sure going forward, as this road, which we have seen, Dr. Pandey, you will agree that we have seen that in last so many period, while we were constructing this road, we have seen one monsoon pass through, and this road has behaved way better than the normal road. I'm sure you will agree to this. So what I am trying to say is that, this such efforts always pay good results. See, we have been trying to, again, Dr. Saraswat, we are trying to, also collaborate with organizations like RDSO for using this slag as ballast material or in the base layer of railways. We have already put up our application to the Ministry of Railway and RDSO. I think CRRI has been assigned assigned and work on that to prepare a report on its sustainable use. We have also informed the Ministry of Railway that we are ready to take up a test patch, like we have created this test patch in the nearby railway project, which is near to us, for development of use of slag in railways. We have also, supplied our slag for barrage making as a part of Kalpsar project here nearby our plant in Bharuch, where the slag is being used, is used for making gabion walls, for making the barrage, where we are finding a good use of this steel slag. We are also, as per standard, the certain applications are allowed. So we have been, doing a lot of exhibitions and participating in a lot of exhibitions to promote use of steel slag in construction industry up to the base layer, at least up to the foundation, etc., where it can be used. So our efforts are always towards, making it useful. And we all know it's a green product. We are not, spoiling the nature. We are only trying to sell our byproduct to the companies, to various users. So for this effort, I again would like to congratulate CRRI, and I also take this opportunity to congratulate our team at AMNS, the research and development team at AMNS, and the project execution team, which has tirelessly worked on this project, and we have completed this project, which has seen a huge success. And a lot of media coverage is given to this Slag, but okay, that media coverage I feel is just a byproduct. We are looking forward to use of Slag in road making, and we are already working with NHAI and to see if we can use the Slag in those bigger projects where we can supply this in bulk quantities. So I only think that I would request the forum and the government agencies is to learn from the experience of other countries and not spend too much time in researching something which the other countries have already done. So we can, expedite this process of, certifying any product for use basis, some research that has happened in other countries also. That's the only appeal I would like to make as industry, so that we have a speedy, acceptance of material. Yeah, so I think that is all. Thanks. Thank you very much for inviting me for this discussion. Thank you so much.
Thank you very much, Mr. Mishra, for connecting with us and for sharing your experience with us. So it's really very nice to know about the research and technicalities associated with the construction of road using steel slag, which is actually a waste product for the steel industries, and that can be efficiently utilized for one of the major infrastructure development, that is road construction. So I keep this forum open for discussion among the speakers now, and shall take few questions from the audience. So we have one person connected with us, Mr. Shiva Kumar from Vizag State, and he has few technical questions. I'll be taking a couple of questions from that. So I think Mr. Satish Pandey, if you can respond. What is the IS standard for using steel slag for road making? So is there any particular standard for it?
So right now, there is a provisions are made under IS 383. So, but those are the provisional provisions. There is no specific guidelines inside it for the utilization of different types of steel slag. So generic type of word like steel slag has been inducted, and partial utilization into plain cement concrete applications has been allowed for under IS 383. So we are in the process to revising the entire BIS standard as per the mandate given by Niti Aayog to us. So by the end of July itself, we will bring out a detailed specification and guidelines along with the design template, which can easily facilitate the utilization of steel slag in road construction activity work. So besides the material properties, entire mixed design mechanism, pavement design mechanism will be incorporated into it, so that the road concessionaire can utilize all those guidelines for the construction of road using processed steel slag aggregate.
Okay, so thank you. So we have another question from him only. What is the best suitable method available for stabilizing steel slag in India?
I think his questions refer to the weathering of steel slag. Mr. Shiva Kumar is from Rashtriya Ispat Nigam Limited. So CRI team has already visited RINL facility in month of February. We have suggested some alternate mechanism to weather the LD slag. So it depends upon plant to plant practices. At last, whatever the weathering practices you adopt, it should not render your steel slag uneconomical at last. So the adoption of the technology should be based on the economic viability, which makes the slag feasible for road construction purpose. So in this regard, depending upon the space availability, type of steel slag, there are different steel slag weathering mechanism is available. As far as the practice in Japan or Nippon Steel is concerned, they have fully mechanized autoclave plant. So in that through that autoclave plant, plant, very effectively the steel slag weathering in a very short span of time can be carried out. But the processing per ton processing cost of the slag through the autoclave mechanism is bit higher. So in the countries like Japan, like where there is an scarcity of natural aggregates, that process is still economical in nature. But we have worked on alternate technology also, and recently we developed one organosilane based, working on organosilane mix compound, which makes the slag aquaphobic or waterphobic in nature. And once there is no penetration of water inside it, so no, there will not be any sort of volumetric expansion. So the initial results are quite encouraging. We intend to do one trial, so it will basically waived out the requirement of weathering in LD slag. So it is a this sort of treatment with a very nominal dose, around 0.1% chemical is required to be added in 1,000 liters of water, and with the help of that we can treat those type of aggregate. So these are the futuristic upcoming technology. Although we have suggested some alternate mechanism to the Tata Steel, like steam aging facility and aging facility based on wetting and drying cycle, and they are effectively utilizing it for the supply of processed LD steel slag aggregate in the construction of NS33. So a section has been already laid under the CRRI supervision on NS33 near Jamshedpur, where we have utilized processed LD steel slag aggregate in granular sub-base and base course layer. But in the case of asphalt mix, that trial was not successful in another road. When we replaced it with 100% processed LD slag aggregate, there was a sort of bleeding after 2-year time. Although the road was completely intact, there was no pothole and cracks, but we found certain amount of bleeding. Besides that, the binder requirement get increased slightly. But under this present study, we developed the different paving composition with LD slag aggregate, which will overcome with this particular problem, and LD slag aggregate can also be utilized in the asphalt mix. So these are the future predicted way map for the utilization of LD slag in road construction activity work. So Paramjit sir also asked about it, like in what way we are proceeding and what is the future roadmap about it. And for the RINL perspective, we have already suggested the particular aging treatment for them, which is remain quite economical to him for the utilization purpose.
Thank you so much. So we have few more technical questions from Mr. Shivakumar. So I would suggest him to kindly connect with you to get more technicalities and queries resolved. So we have one question from Mr. Gautam Banerjee. What is the estimated life of steel slag made in Hazira? So
like we designed it for the 20-year design life period, so that particular road is not supposed to have any sort of major rehabilitation during this design period time. As far as the conventional road in the nearby area or in the nearby section is concerned, the average life of those roads is between 3 to 5 years. So it gets deteriorated within 3 to 4 year time. It is heavily loaded road section, and it basically serves the Adani port and SR ports. So heavy commercial vehicles are moving on that. But this particular road is not going to have any sort of major rehabilitation for 15 to 20 years.
Okay, nice. So we have some comments. Congratulations note for you and your team on this steel slag road construction. And it seems there is a India book and Asia book record also on this road construction.
Yes.
So congratulations. Yeah, please.
Thank you very much, ma'am. Thank you.
Yeah. So what I see here in a way or
other. You are mute. Saraswat sir want to share something.
Yeah, Dr.
I have one suggestion. I think the time has come to look at the commercialization of this technology, either through the steel plants or through a valorization activity, which the steel plants can now pitch in with the technology developed by CRRI to scale up the production of these aggregates based on steel slag for road construction activities. Once the BIS specification is also firmed up, it will become mandatory tomorrow through the MORTH that the steel slag will be used. So at that point in time, unless the production is also organized at scale, you will find that penetration of this into the actual activity will suffer. So my request is there should be a major shift in terms of thinking through the Steel Ministry and as well as through the Ministry of Road Transport as to how to productionize it. And CRRI can transfer technology to the private investors who can set up plants for this preparation of the steel slag. So I think this should be a major initiative in this direction, whether it is the LD slag or the blast furnace slag. I think in both cases, there is a requirement for us to tune it to meet the requirement, and the technology for tuning should be certainly set up at scale. And I am with Mr. Mishra when he says that if there are technologies available abroad and they are suitable for our slags also, I have no hesitation in taking those technologies and scaling up and providing the quantity of the aggregates or the asphalt or the mix which is needed for a variety of applications for our country. Because ultimately, our aim is to stop, destroying our hills and things like that. We need to do that. It doesn't matter. Second part is the cost. See, cost of sustainability is very important. Even though your slag may be 10% costlier, transportation cost may be 1 or 2% higher, it should be ignored to that extent. And the government will be willing to even offset such differences by way of various schemes of subsidies and all that. But the whole idea is that we are achieving sustainability, and no sustainability can be achieved without spending a rupee extra. You have to do that, and that point has to be understood, and accordingly we have to work on that. So I think with the industry and the CRRI and the Steel Ministry, this roadmap should be prepared at the earliest. This is my suggestion.
Sir, you would be happy to know that like recently one NHAI concessionaire constructing NS7 near Hazira has already approached AMNS India to provide 10 lakh ton processed steel slag aggregate for construction of part of NS7, sir.
Excellent, excellent.
Yeah.
So thank you very much, everyone. Thank you very much, sir, for your suggestions and your comments. So here, what I see, in a way or other way, we all are connected with steel somehow. I too belong to SAIL's, Bokaro Steel City, where I am born and brought up. My father worked in SAIL. So it was very nice. It was a personal touch here. Thank you, everyone, once again. It was really great listening to all the speakers today, and was interesting to know about the technology for construction of a road using steel slag. So we have almost reached the end of the session, and I thank all the speakers for connecting with us and sharing your experiences, and our viewers for showing interest in the talks and interacting with our speakers. So with this, I request Mr. UK Guru Vittal, who is one of the senior most scientists holding the position of Chief Scientist at CSIR CRRI, to kindly deliver the closing remarks for the session. Over to you, sir.
Thank you, Ji. Conventionally, the road pavements are constructed using good quality aggregates obtained from sound rocks, gravel, sand and earth. Pavements, the road structure which has been constructed using such materials, they perform well if they have been designed well, considering the loads, environmental effect and the projected traffic. We are constructing more and more kilometerage of roads. So as a result, there is an acute shortage of conventional road construction materials. Apart from that, the environmental effect, environmental degradation of this aggregate as extraction is also very important. So keeping all this into account, CSIR CRRI has been working on using various types of waste materials, how to use them in our road structures. So this has been our goal since last few decades that we have been working on that. And we have done R&D work on a variety of waste materials, industrial waste materials like fly ash, iron and steel slag, copper slag, phosphogypsum, red mud, so many, foundry sand like that. So all these materials, characterization and using it in test structures, that work has been carried out and is still in the progress also in many other ways. The work which has now been carried out by Mr. Satish Pandey ji is very unique in two ways. One is that when we use these waste materials, there are a few things which we have to consider. The material may be either in the powder form or material may be in a rock-like form. So then if it is in a powder form, instead of using it as a, we'll use it in place of gouda, the earth material or the sand material. If it is in the form of a rocks, we crush it and use it in the aggregate. This steel slag is available in both the forms, because when it is being crushed, we get some powder also, we get some crushed aggregate form also. So both have been used, and the two important things which he has realized is that the slag material has been made usable in roadworks, because the steel slag contains an excess of lime, calcium oxide, and how to deal with that is the biggest problem. That problem has been is being worked out, and it's a R&D subject worldwide. And this is one of the novel ways which he has devised for using this steel slag in the roadworks. The second important thing is that when we have used so many other waste materials, we have used it in different component of the road pavement, maybe in the lower layers like the embankment or the lower layers of the road pavement, or maybe in the top layer, maybe in the black top layer, maybe in the cement concrete, like that. But in this particular case study, Mr. Satish Pandey has used the steel slag in all the layers, in every possible manner. There is absolutely no earth, no aggregate, the conventional aggregates in this particular road. Everything is from steel slag. So that's the second novel thing which he has achieved. So on the behalf of for realizing this particular task, for accomplishing this nationally important project, my heartiest congratulations and thanks to Mr. Satish Pandey and his team. And on my own behalf and on the behalf of CSIR CRRI, my respectful thanks are due to Dr. V.K. Saraswat, member Niti Aayog, for gracing this function and blessing us and guiding us right from the beginning of this project, sir. Thank you very much, sir. CSIR CRRI acknowledges with gratitude Ministry of Steel, Government of India for sponsoring this study. My thanks are due to Shri Paramjit Singh, Additional Industrial Advisor, Ministry of Steel, for addressing the participants today. On behalf of CSIR CRRI and the entire project team, I thank various steel manufacturers who have supported us for this project. I thank Shri Aruni Mishra ji, Vice President, ArcelorMittal Nippon Steel India, for his enlightening lecture. I thank our parent body, CSIR, and particularly Science Communication and Dissemination Directorate, Dr. Purnima Rupal and her entire team for organizing this webinar. My thanks are due to Dr. Shikha for expertly anchoring this webinar. I thank Dr. Anjana Agarwal, Director CRRI, for her exemplary leadership. I thank all the viewers of this webinar for joining us. Thank you once again, and Jai Hind.
Thank you, sir, for summarizing the session so nicely and for the closing remarks. So to all the online friends, stay connected with us for the next CSIR Success Story webinar. Bidding you goodbye for now. Stay safe and have a nice day.